So, got to redo the video for section 3.3. I had a typo in there, and I appreciate the catch. Anytime I make a mistake, feel free to let me know. It's important. Now, so we are dealing with average rate of change, and the basic principle is the slope formula, where you have y2 minus y1 over x2 minus x1, and that's equal to slope. And in order to operate the slope, you need two ordered pairs. And the way your book is approaching this is, suppose you have a function like 3x plus 4, and you have a starting spot at 2, and you have an ending spot at 2 plus h. So h is some undefined value at this point in time. And when you hit calculus, that h becomes significant. But right now, you're just trying to teach you how to work with that, okay? So you're going to take the 2, and you're going to plug it into your function, and you're going to get 10. So you have 210 as your ordered pair. You're going to take the 2 plus h. Now, that 2 plus h sometimes creates confusion. So the whole expression replaces the x. So you take this letter x, and you flick it away. You go bink, and you have the 3 and the plus 4 left, but you have this gap that needs to be filled. Well, that gap gets filled by the 2 plus h. So the 3 is that 3, the plus 4 is that plus 4, and this x gets replaced by that expression. So we distribute the 3, so we get 6 plus 3h plus 4. Combining like terms, we have 10 plus 3h. So the other ordered pair is 2 plus h, that's the x value, and then 10 plus 3h. Now you take these two values, this is y2, gets put in place of y2, and then you take your y1, so minus your y1, and then using the x's, here's your x1, or I'm sorry, your x2, and then your x1, so 2 plus h minus 2. You'll end up with 3h over h, and then you cross out your h's and you get your 3. All right. So what if your function is 3x cubed, and you have 1 to 1 plus h? Well, same process. You're going to plug the 1 into your expression, and you're going to get 3. So you have the ordered pair 1, 3. You're going to take the 1 plus h and plug it in, and you've got 1 plus h cubed multiplied by 3. Well, 1 plus h cubed gets you 1 plus 3h plus 3h squared plus h cubed. And then you distribute your 3 through, and you'll have the ordered pair 1 plus h, comma, 3 plus 9h plus 9h squared plus 3h cubed. Okay. So we'll hop over here, and we're going to take the y2. So this piece here is the y2, and here's your y1. And here's your x2, and here's your x1. And you are subtracting, just following the formula. And you end up eliminating your 3's and eliminating your 1's. So you have 9h plus 9h squared plus 3h cubed over h. You factor out an h, and so it would look like this. And then you have the h in the denominator, and what's left in these parentheses is the result. Okay, your problem number 15, this is again heading towards calculus, and it is actually a modification of the slope formula. It's equal to the slope formula, but there's a tweak in there. And the function that you're dealing with is 2x squared minus 3x. Again, I don't need to talk about the tweak other than it is the slope formula modified. And so what ends up happening is you take the x plus h, that quantity, and you're going to square it. So you think of it as x plus h times x plus h, and you FOIL it out or you distribute it out depending on your history with math. So you get x squared plus 2xh plus h squared. And then you're going to have this negative 3 get distributed. So you get negative 3x minus 3h. And we are in a second going to distribute that 2 through. But we're going to pass this negative through and get negative 2x squared plus 3x. All right. Now we're going to travel up to here. When we distribute the 2, we get 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus 2x squared plus 3x all over h. We start eliminating terms that are the same values, but one's positive, one's negative. So we are left with 4xh plus 2h squared minus 3h all over h. Factor out an h, and you got 4x plus 2h minus 3 over h, and your h's cancel, and this is your result. Thank you again for the catch on that one. Now let's turn over. We are talking as well about the ideas of intervals of increasing, decreasing, and maxes and mins. So I have this huge schematic drawn up over here, and I apologize for the mess. But first of all, relative max, relative min. So what you'll do is something that looks like it's a high point is called a relative max. It could be the absolute max, but in this type of environment, because there's another region that goes above that height, it's relative to this area. It's the high point relative to this area, okay? So in a classroom, I might be the tallest person, or somebody else might be the tallest person at 6'1" or 6'2". But there are 6'9" and 6'10" and 7'11" kind of people. And so relative to everybody around me, I'm taller than they are. Or the 6'1" person is taller than everybody, but I'm not the tallest person, so that's the absolute max. So you're gonna have a graph on your graphing calculator, and you'll do the second key and the trace key. And you're gonna find this command called max. You'll hit enter on there. You're gonna move the cursor to the left-hand side of the peak, and you'll hit enter. And you'll get this little triangle shape, looks kind of like an eye. Move the cursor over here, hit the enter, and you'll get this triangle shape. And then hit enter again, and it'll give you what the max is. And in this instance, because it's a 1, the max will occur at 1, and that will be the x value, and the actual maximum is 1. Now, we have the same set of commands for min as well. So second trace, hit minimum, get to the left side, hit enter, and you get your little eyeball. Move to the right side, hit enter, you get your little eyeball. Hit enter a third time. It's going to say guess down at the bottom. Don't bother. Just get the value, and again, it'll be an x value of 3, and then you'll get a as where the minimum occurs, and then the actual value of the minimum is -1. That's a relative minimum. Now, the graph is increasing from -infinity all the way to 1. But we don't include the 1. The 1 is that moment in time when, like, if you throw the ball up and it just hangs there for a second, and then it starts coming down. So from -1 to 1, and then from 3 off to infinity, 3 off to infinity. And that's a union there, and that's where it's increasing. Decreasing is from 1 to 3, but again, not including the 1 and the 3. All right, so I want to do a quick description of example 10 to talk about absolute max. Now you see, this graph ends, and you see how this is the high point and this is the high point in the graph. And you can have an absolute max be met a couple different spots. The absolute max occurs at 2 and at -2, and where it occurs, the height of it is actually 16. So the x values versus the y values. Now the absolute min can occur at an end point, and it looks like it's approximately 10. Now the x value at which it occurs is 3. Okay, hopefully that's helpful, and thank you for the catch again. I will talk to you guys later.